So graph linear inequalities. So if you have, and I'm just going to read this equation, y is greater than negative 4x plus 3. So notice this part looks just like we've been doing all year, the linear, where the negative 4 is your slope, and then the 3 is your y-intercept. So that's stuff that we've been doing all year. The only difference is this right here, saying it's greater than. So the y values, or y is greater than. So I'm going to go ahead and graph it just like we normally have. Okay, so we know that our y-intercept is 3. So I'm going to go 1, 2, 3. And then you have to go by your slope. So it's negative 4, which you can put at negative 4 over 1. So I'm going to go down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. And then I'll go ahead and go up and back just so that I have a full, like the entire line. 1, 2, 3, 4, back 1. So that is going to be our line. So I said this stuff is all the same, so it's still the slope and the y-intercept. The only thing that's different is that that's a greater than. Just like when we were talking about on a number line, greater than, and then you have greater than or equal to. So whenever we were doing on a number line, you used an open circle if it was just greater to show that it can't be equal to. When you're graphing lines, if it's greater than and not equal to, you put a dashed line to show this is where it starts, but it cannot be equal to that line. If it's an or equal to, you put a solid line, just like we've been just doing y equals negative 4x plus 3, where if this was an equal sign, you would just draw the line and that's it. So these are the two types of line you can have, either a dashed line or a solid line. So if it has the equal to, you would make it a solid line. If it doesn't have equal to, you make it a dashed line because it cannot be equal to. So I'm going to go ahead and make my line. So the easiest way to do it is to get a ruler or some straight edge and then just put your pen down, pull it up, put it down, put it up. And then it makes a pretty good dashed line. Now, the way I remember for greater than, sorry, I'm trying to find my pencil. Greater than is always going to be above the line. I'm going to go ahead and write that. Greater is above the line. Less than is always below. I'll move that up. The line. The way I remember it is I draw somebody standing on top of the hill. Remember, this was a negative slope, so it had to go down. And I always use the skateboarder for that to show, okay, if he moved to the right, he would be moving down. So since it's greater than, it needs to be above that person or that skateboarder. So I would shade this side because that's above the line. And it should make sense, like greater than, it says y is greater than. So if you think about this number right here, or that point right there, which is at 1, 2, 3, 4, 0, 4 is definitely greater than negative 1. So if you think about a number line, you would want to shade this direction. Okay? Something that we usually do, or something that you'll see me do, is to check to make sure that this really is a solution. So I'm going to check solution. And the way you do that is you just pick a point in the area where you shaded. So I'm going to pick the point 4, 0. So I'm going to pick 4, 0. Remember, 4 is the x value, 0 is the y value. And I'm going to plug it into this equation. So 0 is greater than negative 4 times 4 plus 3. I just use this equation using whatever my 0 for y and my 4 for x. So then negative 4 times 4 would be negative 16 plus 3. Negative 16 plus 3 is negative 13. 0 is definitely greater than negative 13. So that is a correct solution. So 4, 0 is a solution. If I just had a point and I said, is this point a solution? And say I picked this point right here, negative 2, 1. You can either look at the shaded area and you can say, okay, well, it's not in the shaded region, so it's not a part of the solution. Or you could plug that point in for x and y. So this area over here is also called the solution. This over here is called the solution, just because that's everywhere that if you took any of those points and plugged them in, it would be a correct statement. Okay, let's go ahead and do one where you're given the graph. So if I give you the graph, which is kind of like what your assignment's going to be today, you're not actually going to graph any of them by hand. Okay, so if I gave you this graph and I said write the equation, we know it's going to be in the form y something mx plus b. So remember, you always have y. It used to be y equals mx plus b. The only difference now is instead of it being an equal sign, it's going to either be a greater than or a less than since one side is shaded. So I'm going to go ahead and draw my skateboarder. He's not a very good skateboarder, but and then think about him moving to the right. So our slope, let's go ahead and find our slope first. So from this point to this point, it goes up 1, 2, and over 1, 2, 3. So my slope is 2/3, and it's positive because it's going up. And then my y-intercept is 2. And this is slope. So I'm going to go ahead and plug that in. So we have y, leave space for our inequality, 2/3 x plus 2. So that's our equation of the line. That's what we've been doing, or we've worked on quite a bit this year. Now we just need to decide, is it greater than or less than, and does it have the equal to? So if we look, remember this down here is our solution. So it is shaded below the skateboarder. So notice it's below the skateboarder. So that would mean that it has to be less than. And since it's a solid line, it has to have the or equal to. So since it's shaded below, it's less than. Since it is a solid line, it is or equal to. So that's how we know what to do. So that's our answer. That's what I would use as my solution. Okay, So sometimes you're going to be given the equation and you have to graph it, and sometimes you're going to be given the graph and you have to write the equation. So just pay attention to if it's a solid or a dashed, like that one, and then if it's shaded above or below.